All right, Algebra 2. Welcome back. We just finished Unit 3, and so we're going to start Unit 4 now. And so Unit 4 deals with rationals. So rationals are fractions. Okay, rational comes from ratio. Ratio is a comparison of two numbers, so we're looking at fractions. So rational numbers are any number that can be written as a fraction, a over b, where a and b, both the numerator and denominator, have to come from the integers. So remember, integers are numbers that you see on a number line, like -2, -1, 0, 1, 2, 3, okay, that kind of thing. So that's what a and b have to be. The only exception is b, the denominator cannot be 0. A can be 0, though. Right, and then irrational numbers are numbers that cannot be turned into a fraction, okay, so that means they're not rational. Or if you were to compare their decimal, the decimal goes on forever, like across your computer or your calculator, without a pattern. Okay, so it doesn't repeat any numbers, there's no pattern to it. It doesn't ever stop, it just goes on forever. All right, so let's look at rational numbers again. So identify the numbers that are rational, we'll put an R, and then which ones are irrational, we'll put an I. So 3/4, so that is rational because the top and the bottom are integers, right? And if you were to look at its decimal, it stops. It's 0.75, right? So we'll put R for rational. 3.14, that decimal stops, so it's rational also. 5/0, right? So you can't divide by 0, and so it's, we'll call it irrational. Square root of 5. So now square root of 5, you can't simplify that, but if you were to look at its decimal in your calculator, the decimal goes on forever and there's no repeating pattern, so we'll call that irrational. 23, that's the same as 23/1, and both 23 and 1 come from the integers, so this would be rational. -1, same reasoning as number 5. -1 can be written as -1/1, and both of those come from the integers, so that's rational. 0 can be written as 0/1, that's the same as 0, and both the top and the bottom come from the integers, so that's rational. Pi, right, now if you put pi in your calculator, it goes on forever in your calculator, 3.14, and it just keeps going, and there's no repeating pattern, so that's an irrational number. Let's see, the square root of 16. Now, if you simplify square root of 16, that's 4, and 4 can be written as 4/1, and so 4 and 1 both come from the integers. Also, if you put in square root of 16 in the calculator, you'll see it's exactly 4, and it's not a decimal that goes on forever, so this is rational. Right? So just because it's a square root doesn't mean that it's irrational. You have to simplify. All right, so let's keep going. All right, so in fractions, we get what's called excluded values. So those are values that make the denominator 0. All right, so values that make the denominator 0, and we can't have that because you can't divide by 0. All right, and so to find it, you set the denominator equal to 0 and solve it. So it's all based off of the bottom, the denominator. All right, so let's state the excluded values for these. So again, it's all based off the bottom. It doesn't matter what's in the numerator. So if we set x minus 2 times x plus 3 equal to 0 on the bottom and solve it, well, since it's already factored for us, we can set x minus 2 equal to 0 and x plus 3 equal to 0. And if we solve it, we're going to get 2 and -3. Right? And we can see why 2 is going to be an excluded value, because if I plug 2 in here and here, 2 minus 2 is 0, 2 plus 3 is 5, and 0 times 5 is 0, and now I'm trying to divide by 0, right? So this all goes to 0 on the bottom, and I can't have that. So, and then the same thing works for -3. If I plug -3 in for x, it's going to make the denominator 0, all right? All right, so number 2, we have 4x and x plus 5 in the denominator. So again, if we set that equal to 0 and we solve for x, we set 4x equal to 0 and x plus 5 equal to 0 and solve it, we're going to get 0 for the 4x and then negative 5 for the x plus 5. All right, number 3, we have two fractions. So here we're going to set 2x equal to 0. And if we set 7 equal to 0, well, there's nothing to solve. So there's no variable. So we can ignore that one. That one doesn't have an excluded value. But the 2x does. And so if we set that equal to 0 and solve it, we're going to get 0. Right? So just because it's a fraction doesn't mean there's necessarily an excluded value. You have to have at least a variable in the denominator. All right, so when we simplify fractions, we want to think of monomials, okay, and binomials and trinomials, okay? When we have a monomial and it's being divided by a monomial, that's a single term, there's no adding or subtracting it. We can simplify the coefficients, we can simplify the exponents when the variables are the same. So remember the rules of exponents. When we're dividing, we subtract exponents, all right, and we can simplify coefficients. So for example, 3x to the 5th over 12x squared, we can simplify 3 over 12. Okay, that's 1 over 4, because we're just dividing by 3. And then x to the 5th over x squared, we subtract the exponents. All right, and so I'm bringing the 2 to the top to do the subtraction. And so that becomes x to the 3rd on top. Okay, let's see, when we have binomials, okay, binomial can cancel with like binomials that have to be exactly the same. So on this example, an x plus 3 and an x plus 3 can cancel out because they're exactly the same. But the x minus 6 on top and the x plus 6, they're not exactly the same. And so that means that you can't cross them out. And you're not even allowed to cancel part of them out. Right? You have to just leave the whole binomial the way it is. So you can only cancel like binomials with like binomials if they're exactly the same. If any part of it is different, then you can't cancel it out. All right, so let's try some of these other ones. So we're going to simplify and state the excluded values. So you're going to state the excluded values first before you cancel things out. All right, so the excluded values for number 1, since the denominator is already factored for us, we have 4x, we could set that equal to 0. We're going to get 0. And x plus 6, if we set that equal to 0, you're going to get negative 6. All right, so those are the excluded values. Now we want to go ahead and simplify this fraction. Well, I have an x plus 6 binomial on top and bottom. I can cancel those out. The 10 over 4, so now I have monomials. I have a monomial on top and monomial on the bottom. I can cancel by dividing by 2. All right, and then the x to the 5th over x, I can subtract the exponent, so that exponent is going to be a 4. All right, so now I just have to be careful what I've canceled and what I haven't. So on top, it looks like I have a 5x to the 4th left over. And on the bottom is a 2. All right. All right, so number 2, we have to make sure everything's factored before we start canceling. So we're going to factor this x squared minus 4. Okay, so that's x plus 2, x minus 2. All right, and then I have this x minus 2 on top. When I have binomials, I like to put them in parentheses because I keep those together and I remind myself not to cancel part of them out. It's the whole thing or none of it. All right, so my excluded values, again, come from the denominator. So I can set x plus 2 equal to 0. And if I solve it, I get negative 2. And then x minus 2, I'm going to get positive 2. Now I can go ahead and cancel. So I have an x minus 2 on top and another one on the bottom. So when everything cancels off the top, you have to leave something on top. So we're going to leave a 1 up there. Right? So what's left over is 1 over x plus 2. Right? You can't just leave x plus 2 in the denominator without something being on top. Wouldn't look right. Okay. Let's see, number 3. So again, it's already factored for us. So we set 2x equals 0. We're going to get 0. And if we set x minus 5 equal to 0 and solve it, we're going to get 5. All right, now we want to go ahead and cancel. All right. The x plus 5 and the x minus 5 are not exactly the same. One's plus, one's minus, so you can't cancel those out. All right, but the negative 4 over 2, we can divide by 2, so that's going to go to negative 2 and that 2 will cancel out, it just become a 1. The x to the third over x, I can again subtract the exponents. So it looks like what's left is negative 2x squared, x plus 5, over x minus 5. Again, it helps, I think, a lot to keep the binomials in parentheses. So it keeps you from trying to cancel them out. Okay. Number 4. Well, let's see. We can factor the top still, and we can factor the bottom. So we want to go ahead and factor. The top, let's see, we can use the x for factoring that one. So 2's on top, negative 3's on the bottom. So that's negative 2 and negative 1. So on top it's going to be x minus 2, x minus 1. And then on the bottom, I'm going to pull that 2 out. Okay, I'll do it over here so you can see it. X squared minus 1's left over. But then x squared minus 1's a difference of squares, so that'll actually go further into x plus 1 and x minus 1. All right, so everything's factored. Now we want to get our excluded values. So on the bottom, that 2, since there's no x with it, there's no variable, we can ignore that. The x plus 1, we can set that equal to 0 and solve it. We're going to get negative 1. And then the x minus 1, set that equal to 0 and solve it. Get positive 1. Now we can go ahead and cancel. So I have an x minus 1 on top, and I can see there's another one at the bottom. They're exactly the same. And that looks like it. The x minus 2, that 2 cannot cancel with the 2 that's on the bottom because the x minus 2 belongs to the binomial. And that 2 in very front at the bottom is a monomial. All right, so all I have now is x minus 2 on top. On the bottom I have a 2 and then an x plus 1 on the bottom. All right, so let's keep going. All right, so number 4, looks like we can factor the top and factor the bottom again. So we have this trinomial. Use the x, so negative 14's on top and 5's on the bottom. So that's 7 and negative 2. So x plus 7, x minus 2 on top. On the bottom, I have to pull that 3 out. That's a GCF. I'm left with x squared minus 4. But x squared minus 4 is a difference of squares, so that's going to actually go further. So just like the other one. So x plus 2, x minus 2. All right. The excluded values, again, come from the denominator. The 3 on the bottom, since there's no x with it, we can ignore the 3. The x plus 2, if you set that equal to 0, you're going to get negative 2. And if you set x minus 2 equal to 0, you get positive 2. Now we'll go ahead and cancel what we can. We have an x minus 2 on top and bottom. We'll cancel those out. And that looks like it. So x plus 7 on top with a 3 and an x plus 2 on the bottom. All right, number 5. Here we can factor the top and factor the bottom because they're trinomials. So use the x on both of them. So here we have 6, because remember, multiply 2 times 3 gives us 6 on top, 7 on the bottom. So the two numbers are 6 and 1. But this time we're leading off with a 2, so we have to remember divide by 2 and simplify. 6 over 2 is 3. 1/2 doesn't simplify. All right, so this top numerator factor will be x plus 3 with a 2x plus 1. Okay, on the bottom, I'll do the x over here so you can see it. 12's on top, 7's on the bottom, 4 and 3. We don't divide by anything because it's a 1 in front. So x plus 4, x plus 3. All right, so everything's factored. Now we'll get our excluded values. So set x plus 4 equal to 0 and solve it, we get negative 4. Set x plus 3 equal to 0 and solve it, we get negative 3. We'll cancel the x plus 3's out, and we're left with 2x plus 1 and x plus 4. All right, number 6. We have a trinomial again, so we have to use the x. 36 on top, 20's on the bottom. Let's see, what's that? 18 and 2, I believe. Yep, So x plus 18, x plus 2 on top. On the bottom, we're going to pull that GCF out. I can see that they both have x's. I'm going to pull the x out. I'm left with x squared minus 4. Again, x squared minus 4 is a difference of squares, so that's going to go further. X plus 2 and x minus 2. All right, our excluded values set the denominator is equal to 0. So we can set x equal to 0. We're going to get 0. Set x plus 2 equal to 0. We get negative 2. And x minus 2 equal to 0. We solve it. We get x equals 2. We can cancel x plus 2 on top with an x plus 2 on the bottom. And we're left with x plus 18 over x times x minus 2. All right, so that's how you simplify fractions. So remember, we factor the top, we factor the bottom, and then find our excluded values, and then we cancel like terms out. Okay, especially with the binomials, you have to cancel a like binomial with the exact same like binomial if you have it. If they're not exactly the same, then you can't cancel them. Okay, so now multiplication and division of fractions, same as elementary school. With multiplication, with polynomials, we factor everything. All right, so we factor the top, we factor the bottom. Then with multiplication, we're allowed to cross cancel. So if you have something diagonally or top and bottom, you can cancel like terms out. Okay, and then we just multiply what's left. And then division, we turned it into a multiplication problem, but we flipped the right side fraction. All right, so on this first one, x squared minus 4 factors into x plus 2, x minus 2. All right, so now we can go ahead and cancel. Remember, x minus 2 on this top left, it's a binomial, so it helps to put it in parentheses. So you can see that this x minus 2 can cancel with the other one. So you can cancel diagonally, or top and bottom. You just can't cancel top with top or bottom with bottom. Diagonally, with the 4 and the 16, we can divide by 4. So on top, what's left is a 4, and on the bottom looks like x plus 2. All right, and again, that 2 and the 4 you can't cancel out because that 2 at the bottom belongs to the binomial, x plus 2, and you can't break it up. All right, so then with division, we're going to turn to a multiplication problem, and we flip the left side. I'm sorry, the right side only. All right, so x minus 3 over 6x squared times 9x over x minus 3. So now it's multiplication. We can cross cancel. All right, 9 and the 6, I could divide by 3, so that 6 becomes a 2, the 9 becomes a 3. And then I can subtract the exponents. Okay, so the x on top and the x squared on the bottom, I could subtract the exponents and it becomes an x to the first on the bottom. So then what's left is 3 and then 2x. All right, so let's go ahead and do these ones. So we're multiplying. We don't factor anything. Everything's already been factored for us, so that's kind of nice. So we want to look for like binomials. I have an x plus 3 I can cancel out. Let's see, diagonally with the 8 and the 12 I could divide by 4. It becomes a 2, and this becomes a 3. The x squared and the x, I can subtract the exponents, so that x squared becomes just x. All right, so what's on top? 3x minus 3 over, it's like 2. That's it. All right, number 8, we can factor. So 4x minus 16, there's a GCF there. I can pull a 4 out. I'm just going to cross that out and put its factored form instead. Or you can rewrite the whole thing. X squared minus 16, that's a difference of squares. That's x plus 4 and x minus 4. All right, so now let's go ahead and cancel what we can. Looks like the x minus 4 binomial can cancel. Let's see, diagonally here I have an x and an x, so those two will cancel. The 6 and the 4 I can divide by 2. That 6 turns to a 3 and that 4 turns to a 2. And that looks like it. Now I have this 2 and the 4. Okay, I can multiply those two together. So just be careful with that. So on top I have a 3 with an x plus 4. On the bottom I have 2 times 4, which is going to be 8. And that's it. Right, so it's just 3x plus 4 over 8. And we don't want to distribute back in, so we're not going to distribute the 3 back in because we want to leave our answers in factored form. All right, so don't multiply these things back out. All right, number 9. Let's see, I have a trinomial on top, so I can factor that. Use the x. So 9 and 6. So two numbers that multiply to 9, but add to 6 are 3 and 3. So on top, I'll just rewrite it. X plus 3, x plus 3. On the bottom, I have a difference of squares. That's x plus 3, x minus 3 times 3x minus 9. There's a GCF in there I can pull out. I'm going to pull a 3 out, so that's x minus 3. And then on the bottom is just x plus 3. Put it in parentheses. All right, so now we want to go ahead and cancel. Let's see, I can do top with top and bottom. Sorry, top with bottom. Let's see, I have another diagonal x plus 3 with an x plus 3. I can cancel out. I have an x minus 3 diagonal with another x minus 3. And that looks like it. So the only thing left is 3. If you want to write 3 over 1, you can, but that's the same as just 3. All right, number 10. All right, so almost all of it's already factored. The x squared minus 4, I'm going to write that as a fraction. I can put it over 1. And then factor it. It's a difference of squares. So it's x plus 2, x minus 2. Right, the x plus 2 on the bottom, I'm just going to put in parentheses so you can see that I can cancel them out because they're exactly the same. And that looks like it. So everything canceled off the bottom. So my final answer is going to be 3, x plus 4, x minus 5, and then x minus 2. All right, 11. Let's see, this is all monomial terms. There's no binomials, nothing to factor because there's no adding or subtracting anywhere in this. So this is kind of a problem. The easiest thing to do is just to multiply straight across. Turn it into one fraction and then simplify the one fraction instead of doing all the diagonal canceling because it gets real messy in here. All right, so I can multiply 2 times 7, that's 14. X times x squared, I add the exponents, that's x to the third. And then y times y is y squared. All right, and then on the bottom, 14 times 4, I can multiply that together. That's 56. Let's see, I have an x in there by itself. I'll just line up the x. I have a y to the third, but no other y, so I'll just leave it as y to the third next. And then z times z to the fourth is z to the fifth. All right, so now I'm going to go ahead and simplify this fraction. So 14 over 56, I can simplify that. You can divide by 2 and keep dividing, but I know 14 goes into both of them. So 14 goes into 56 4 times. X to the third over x, I can subtract the exponents. So that x to the third becomes x squared. Y squared over y to the third, I can subtract the exponents. So that y to the third just becomes a y on the bottom. And then z to the fifth on the bottom, there's no z's on top to cancel. So it looks like what's left is x squared on top. On the bottom, I have a 4. And then the x canceled. The y was left over. And the z to the fifth was left over. Again, if you want to do it from the original problem and do all the diagonal canceling, you can. Just make sure that you keep clear of what's been canceled out and what hasn't so you can multiply back out. All right, and then division, just like multiplication, change to multiplication, and we flip it, and then we just treat it just like a multiplication problem. So x to the third minus 8, that's a difference of cubes. So this is going to factor using SOP. from the last unit. We cube root these two terms. So it becomes x and 2, and then x squared 4, and then 2x all over 30 times, we flip the fraction, so 15 goes on top. The x squared minus 4 is a difference of squares, so it comes to the bottom, and we're going to factor into x plus 2x minus 2. All right, everything's factored, now we can cancel. Let's see, I have an x minus 2 diagonal with an x minus 2. 15 and 30 I can cancel out because 15 goes into 15 one time and 15 goes into 32 times. And that's going to be it because the x squared plus 2x plus 4, that trinomial doesn't factor any further. So what's on top is x squared plus 2x plus 4. On the bottom I have a 2, and then there's an x plus 2 binomial. And that's it. All right, and then 13, this last one. Again, we're going to change this multiplication, and we flip the right side fraction. So don't forget to flip it. We're going to factor. Okay, got to factor everything. So x squared minus 25, that's a difference of squares. So that's x plus 5, x minus 5. And then x minus 3 is on the bottom. Okay, that x plus 5 is coming to the bottom. And then that x squared minus x minus 6, that's a trinomial, so we're going to have to factor that using the x. So negative 6 goes on top and negative 1's on the bottom. It's negative 3 and 2. So it becomes x minus 3, x plus 2. All right, everything's factored, now we'll cancel. X plus 5 can cancel with x plus 5. X minus 3 can cancel with the x minus 3. And that looks like it. So our final answer, x minus 5 and x plus 2. All right, and that's it.